I love when authors slow down and luxuriate a little in describing the natural environment the characters are moving through. Even if the environment doesn't explicitly have those supernatural fantasy elements, it brings a sense of wonder to the narrative. Sometimes this ends up being a real dreamlike reverie with a lot of beautiful language. Sometimes this is more of a grand adventure. Sometimes it's characters who've spent years in the city rediscovering the beauty of nature. Sometimes the character is literally looking at an ecology they designed themselves. Sometimes the world is very much our Earth, but viewed by supernatural figures who bring an otherworldly perspective to it. Very often the story is hard science fiction, but it's still presented in that beautiful, larger-than-life kind of way. And I think part of the reason for this is that science fiction and fantasy world-building conventions have very different icebergs for what details are explicitly shown and what details remain in the background, informing the story without intruding. Specifically, I think it's more of a genre convention that science fiction writers are expected to more explicitly describe the environment they're writing about and focus on its unusual attributes and really make the readers aware that the story is happening in a very different place. This is very different from the fantasy iceberg, which foregrounds a very different set of considerations. And in general, I think a lot of what I'm aiming to do with this fantasy map generating project is support world building that has that deep, satisfying iceberg. In no novel or TTRPG campaign or video game does the whole ecosystem of every location on the map need to bubble up to the surface. But insofar as it informs the location of population centers, or the setup of societies, or even those slow, luxurious descriptions of the characters' travel interludes, it's worth figuring out what the landscape looks like. Even if the precise details don't matter, when it does rise above the surface and become visible, it'll make the overall setting and story that much richer. With all that in mind, welcome back to Multiversal Map Room, where we're creating fantasy map generation software 1 week at a time. This week, we're building biomes into the map. So, at this point we can generate maps of terrain and bodies of water and the associated climates, and this already works pretty well. Here are a bunch more of the maps we can build using the software so far. And these look pretty detailed and varied, and of course we could also show climate variables for any of these. So going from this to biome labeling isn't that different in principle, right? We can just group together regions of similar terrain and temperature and precipitation and assert that those are the same biome. The steps we've taken so far have really paved the way for us to identify biomes. One thing I wanted to avoid here was having too many biomes that feel too similar. In something like Minecraft, the user is really going to see every single pixel they stand on, and so a bunch of really similar biomes introduces subtle gradations. In the context of fantasy world building, that's not necessary, and so we can use a broader brush to describe more disparate biomes. In fact, we're going to want to find clusters of pixels that are very similar within cluster and very different between clusters, and then assign each of those clusters its own discrete biome. Specifically, we'll be using k-means clustering to make that happen. This is an old, well-established statistical technique that tries to divide pixels into sets so that each set is as similar within, but different from the others as possible. And this is a pretty decent way to start dividing up biomes, right? We can plug in data like climate and elevation and steepness and distance to bodies of water, and use k-means clustering to find clusters of similar pixels and give each of those clusters a name and call it a biome. Unfortunately, when I threw all the data in, this worked pretty poorly and gave us a few very large clusters without much intuition for what biomes they should refer to. As with a lot of these cool statistical methods, straight out of the box, it doesn't really end up giving us the intuition of what we want to do. So instead, we end up first dividing up pixels like this and giving each of these 6 separate categories of pixel its own k-means clustering classifier. We treat volcanoes and craters completely separately from everything else because those pixels often have really extreme conditions, and k-means clustering is going to care too much about those when it's picking optimal clusters. We generate 100 maps with random but plausible latitudes and ocean coverage. We figure out which of those 6 buckets each land pixel on each of those maps falls into, and then we run k-means clustering on all the pixels in each of these 6 buckets. One remaining technical challenge is figuring out how many clusters, or how many biomes, we need to assign pixels to. Fortunately, we can use something called the silhouette score, which is a measure of how much sense it makes to split the pixels up into any given number of clusters. We just pick the best score here and split the pixels up accordingly. For example, for deserts, we get by far the highest silhouette score with just 2 clusters. This gives us 2 biomes, which we can name by looking at the attributes of the pixels in each of those 2 clusters. For example, one cluster is hot and dry, and the other is cold and dry, so I'm just going to call those desert and tundra, respectively. And after that process, here are the names I came up with. These are very ad hoc, but do approximately match real-world biomes. And you'll notice that the very special circumstances of craters and volcanoes, where you have a lot of steepness and often extreme precipitation or extreme temperatures, those have a lot more categories than anything else. As we see later, most of the map will be covered by what we're calling the normal biomes, so those are kind of the ones that matter the most. And earlier I mentioned that we randomly generated 100 maps to generate data to do this k-means clustering and assign a biome to each pixel. On this graph, the vertical axis shows the number of maps that have each biome, and the horizontal axis is the share of the map covered by each biome for maps where it does show up. You'll note that the horizontal scale is logarithmic, so each step forward is a factor of 10. We need to do this because a few large biomes tend to dominate the maps, and on a linear scale it would look like this, which is not very readable. So I think what's cool about this is that some of the most common biomes don't appear on every map. Changing the latitude and ocean coverages really do change what biomes you're going to get. And these dots on the graph are all just averages, of course. When we look at the maps, we end up with a really wide range of biome assignments. Like, here's a map that when we assign biomes to it, it's plains in the north, forests around the middle, and rainforest at the bottom, with very few other biome types, except in the steepest areas and right around the lakes and rivers and coastlines. Not every map is going to end up this cut and dry, but also this is kind of a reasonable looking map for 3 big bioregions. We tend to get maps like this if the difference in latitude between the top and bottom of the map is very large. Conversely, here's another map where we've configured things to be lower in latitude and higher in ocean coverage with some big interior lakes in the north. And on this map, nearly everything turns out to be rainforest, except some mountains and craters and shoreline regions. And that makes sense. This is what we'd expect from a way wetter and warmer map with big lakes and a lot of rivers. This map also has a couple spots of the very rare volcanic cloud forest biome, which happens in areas around volcanoes with very high precipitation levels. I've circled them here so you can see them because they're quite small. In the real world, this kind of biome exists around volcanoes in Costa Rica and Nicaragua, and I'm really pleased that the map generation algorithm we have here can kind of replicate that. Including rare biomes like the cloud forest, in my opinion, starts to get us closer to some of the more heightened, larger-than-life fantasy elements of what we're trying to do here. Like on this map, where there's one big main land mass and an ocean all around it, virtually the entire coastline is tagged as coastal cliffs because it slopes down towards the ocean so steeply. You can see that in the pixels in pink on this map all the way around the edge of that main landmass. So these coastlines might have fjords or the kind of long steep cliffs you'd see in Chile in the real world, for example. On this map, which is fairly far north and which has one big landmass in the center, you get big swaths of the 2 main mountain biomes. There's alpine forest throughout the big mountain ranges, but in the northern part of that big central elevation, you're very likely above the tree line, and so this area is likely just bare rock or glaciers. This interplay of altitude and latitude means that the transition zone between alpine forest and glacial mountains is blurry, which feels fairly realistic. And finally, this map, which is set up to be cool and dry, has some huge areas of desert throughout the big eastern continent, including some cool, dry areas quite close to the coast. There's also a lot more temperate areas, including the south and along the coast, but some fairly large patches of desert that, from a world building perspective, would be hard to traverse and probably fairly low density in terms of population and settlements. So, from here, what's coming next for this project? As far as I'm concerned, this wraps up the first of 3 phases. We now have a pretty good handle on how to build the physical geography of the world, including terrain and magic and climates and biomes. Next up is the social geography, the settlements and polities and trade routes and transportation networks. To be entirely honest, that second phase is the part of the project I'm most excited about, and it's probably the part that's going to consume the most of the series because that's what makes a world feel really fleshed out. And then finally, from there, I need to do all the stuff that makes this into actually usable standalone software, like making this all GIS compatible and building an interface for feature names and packaging this up as something you could reasonably run yourself. I realize this has become kind of an ambitious project, but I really want to be able to release world building software that actually fills the current void in the market, so I think this is what that's going to take. Anyway, that's all for this week. As always, I'm grateful for feedback and suggestions, so don't hesitate to leave a reply. Thanks for watching all the way to the end, and I'll see you next time.